Ringspann is one of the leading manufacturer of wide range of freewheel devices. Let us see Ringspann's solution and benefit for multiple drive conveyor system with 4 scenarios. A multi-drive conveyor has 4 drives. Drive 1, 2 and 3 are in continuous operation. Drive 4 is standby. Ringspann Overrunning Clutch FBE is fixed on conveyor pulley shaft and gearbox output shaft for engaging and disengaging drives. Ringspann Backstop FXRW is fixed on gearbox intermediate shaft to prevent reverse rotation of conveyor pulley. Ringspann Torquelimiting Backstop has flange, inner and outer ring, sprag cage, friction pads and spring. FBE freewheel has coupling, inner and outer ring, sprag cage, bearing and oil seal. First scenario, when conveyor is started. As motor starts, gearbox and inner ring of backstop starts rotating. With increased speed, centrifugal force on sprag lifts it off from position and create gap between sprag and outer ring. During running, contactless wear-free operation of backstop provide extended service life. For clutch, inner ring is fixed on gearbox output shaft and outer ring is connected to coupling fixed on conveyor shaft. When motor starts, clutch inner ring rotates in same direction of gearbox shaft. Frictional force between inner ring and sprag rotates sprag from its axis and get locked between inner and outer ring races. Compression forces enable torque transmission from inner to outer ring. As standby motor is in switch-off condition, there is no rotation of inner ring and backstop is in locked condition. For standby clutch, coupling fixed on pulley shaft will facilitate rotating of outer ring in same direction of conveyor pulley. This enables sprag to shift and disengage from contact of outer ring, allowing clutch to overrun inner ring connected to gearbox shaft. Second scenario, when third drive is stopped and changed to standby drive. If conveyor is not running full capacity, third drive can be stopped to reduce motor power consumption. When third drive is stopped, speed at backstop reduces gradually with motor speed until springs in the cage moves the sprag to its locking position. For overrunning clutch, as motor is stopped, speed at inner ring reduces gradually to stop position. As conveyor pulley is still rotating, outer ring of clutch will rotate in same direction of conveyor pulley. Due to sprag profile, outer ring disengages from sprag, allowing clutch to overrun inner ring connected to gearbox shaft. Third scenario, standby drive is connected to load. Now, clutch is in overrunning mode. As motor is started, gearbox shaft and inner ring of backstop also starts rotating. With increasing motor speed, centrifugal force on sprag enables liftoff from its position, allowing torque transmission. Clutch is now shifted from overrunning to torque transmission mode. With gradual increase in frictional force between inner ring and sprag, which eventually will engage sprag with outer ring, resulting in torque transmission to conveyor shaft. Fourth scenario, when conveyor stops. As motor is stopped, speed at backstop inner ring reduces to 0, bringing sprag to lock condition. However, Due to load on conveyor, inner ring tends to rotate in reverse direction. But Backstop doesn't allow this reverse rotation as sprag is in lock condition for all the drives. For clutch, as conveyor pulley moves backward, direction of outer ring reverses. Due to directional change, sprag are rotated to its engaged position and locked between outer and inner ring. Here, reverse torque from clutch is transmitted to Backstop, which is already in locked condition, thereby preventing any further rotation of conveyor pulley. Components of torque limiting backstop. Torque limiting backstop has inner, outer ring, sprag cage, friction pad, flange and spring. Outer ring backstop is placed between two friction pads on both sides and held in position by a preset force generated by springs on mounting flange. Working of torque limiting backstop. When conveyor stops, complete back driving torque generated due to load on conveyor acts on first backstop. As torque exceed preset spring force, outer ring slips. Partial backload of conveyor is absorbed by first backstop and remaining is transferred to second, third and fourth backstop sequentially. Slipping of backstop enables equal load distribution between all the drives. Benefits of using Ringspann clutch and backstop in multiple drive conveyor. Uninterrupted production. Flexibility to engage or disengage drive without stopping conveyor in case of a motor failure or conveyor is not running at full load. Optimum design. Cost-effective solution with torque limiting backstop. Equal load distribution between the drives and drive system can be optimized. Safe environment for maintenance as no human intervention required to engage or disengage the drive. Ringspann products for conveyor drive system. Electro-hydraulic thruster brake for stopping conveyor. Backstop to prevent reverse rotation of gearbox shaft. Shrink disc to connect hollow shaft of gearbox to pulley shaft. Cone clamping element for keyless connection of pulley drum to shaft. Coupling as per application requirement. Low-speed backstop fixed on pulley shaft to prevent reverse rotation of conveyor. Hydraulic brake for emergency stopping. Brake control system for downhill conveyor. Your benefit is our motivation. For more information, please visit our website